Hello friends, now in this video we will see the operations on the real number. I will explain all the basic before exercise 1.5 and also I will explain all the short examples before exercise 1.5, and in my second video I will explain exercise 1.5. I will give the link of that video in the description box as well as in the comment section. Okay, now let us start. Operations on real numbers. You have learned in earlier classes that rational numbers satisfy the commutative, associative and the distributive laws for addition and the multiplication. Okay. Moreover, if we add, subtract, multiply or divide except by 0 two rational numbers, we still get a rational number. That is, rational numbers are closed with respect to addition, subtraction, multiplication and division. If we add the two rational numbers, we again get the rational numbers. If we subtract the two rational numbers, subtraction of the two rational numbers, we again get the rational numbers, and multiplication of the two rational numbers, we again get the rational numbers. Division of the rational numbers, again we get the rational numbers, and that's why we say that they are the closed under these all the operations. In turn out that irrational numbers also satisfy the commutative, associative and the distributive laws for addition and the multiplication. However, the sum, difference, quotient and the products of irrational numbers are not always irrational. Okay. For example, that is here root x plus in bracket minus root x, and here we get the 0. Next, subtraction, root 2 minus root 2, get the 0. Root 3 into root 3, here we get the 3, and that's why these are the irrational numbers, but their result is not the irrational numbers. Okay, and the division of the irrational numbers, here we get 1. Okay, all these are the irrational numbers. Okay, and hence that is a sum, difference, multiplications and the divisions are not always irrational numbers. Let us look at what happens when we add and multiply a rational number with an irrational number. For example, root 3 is irrational number, and if we add the rational number 2 with root 3, that is a 2 plus root 3, and if we multiply this irrational number root 3 with the number 2, which is the rational number, then what will happen? Okay, now here we know that root 3 has non-terminating, non-recurring decimal expansion. Okay, and the same is true for 2 plus root 3. Now this is root 3 is a non-terminating, non-recurring, and if we add it, again we get the non-terminating, non-recurring. Okay, and therefore this is also irrational number. Then here, if it 2 into root 3, we will get 1.73 and dash dash dash. Okay, and if we multiplied it with the 2, again till we get the irrational number. Okay, in this way, that is if we add the rational with the irrational, we get the irrational number. If we multiplied the rational with the irrational, we get irrational numbers, and therefore both 2 plus root 3 and 2 root 3 are also irrational numbers. Now check next example whether 7 root 5, 7 upon root 5, 2 plus root 2 plus 21, pi minus 2 are irrational numbers or not. Okay, now see this here, root of 5 means what? 2.236 and dash dash. Root 2 means what? 1.4142 and dash dash. Okay, it's a non-terminating and the non-recurring. And also for the pi, it is a 3.1415 and up to the dash dash. Now, if I multiplied this root 5 with the 7, then what I will get? This is 7 into 2.236. Then I will get here 15.652 and dash dash. This is also non-terminating and non-recurring. And in this way, if we multiplied the irrational with the rational, we get the irrational number. Next, 7 upon root 5. Now here we will rationalize the denominator, and for that we are multiplied numerator and the denominator by root 5. That is 7 into root 5 upon root 5 into root 5. Here you will get 5. Okay. Now what about here? The 7 into root 5. Here we have the 15.652. And if we divide it with 5, then again here we will get the irrational numbers. That is 3.1304 and dash dash. Next, similar is also here, root 2 plus 21. Then what about the root 2? Root 2 is a 1.4142. That is, in 1 we add the 21. You will get here 22, and the remaining part will be as it is. And therefore this number is also non-terminating and the non-recurring. Pi minus 2. Pi is a 3.1415. And if we subtract with the 2, then you will get 1.1415 dash dash. This is also non-terminating and the non-recurring. All these are the non-terminating, non-recurring decimals. See, all these are the irrational. So, these all are the irrational numbers. Now, let us see what generally happens if we add, subtract, multiply, divide, take square roots, and even nth root of these irrational numbers, where n is any natural number. Let us look at some examples. Now see this here. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. Now the solution, 2 root 2 plus 5 root 3 plus root 5 minus 3 root 3. Collect the similar term, like terms. That is a 2 root 2 here and only the root 2. Collect here 2 root 2 plus root 2. Then here is a 1, 2 plus 1, that is a 3. Here you will get 3 root 2. What about the next? 5 root 3 minus 3 root 3. Therefore, take the common root 3. 5 minus 3. You will get 2 root 3. Okay. In this way, we can add it. And we are getting the irrational numbers. Multiply 6 root 5 by the 2 root 5. And therefore, here 6 root 5 into 2 root 5. 6 into 2 multiplication, that is 12. And root 5 into root 5, you will get here 5. How it is? We can write it as root 5 into root 5. Here you will get a root of 25, and that is nothing but the 5. Therefore, root 5 into root 5, you are getting the 5. 12 into 5, here 60. Now the next, divide 8 root 15 by 2 root 3. See this here, 8 root 15. Root of 15, 8 here, root of 15 divided by 2 root 3. Now here I will write here root 15 can be written as 5 into 3, and this whole divided by 2 root 3, and their division 2 4 8. Here separate this root 5 into root 3, this whole divided by root 3. Root 3 get cancelled, and here you are getting the root 5. Okay, that is the 4 root 5. Okay, you can simplify this like this. Now the next, these examples may lead you to expect the following facts which are true. What are that? The sum or the difference of rational number and an irrational number is irrational. The product or the quotient of non-zero rational number with irrational number, that is also irrational number. If we add, subtract, multiply or divide two irrationals, the result may be rational or irrational. Okay. Next, we now show how to find root x for any given positive real number x geometrically. How to find out it? I will explain. For example, let us find it for x is equals to 3.5 unit. That is, we find a root of 3.5. You can take 3.5 centimeter. I am here saying that it is 3.5 unit. We will take 3.5 centimeter geometrically. Now see this here. Mark the distance of 3.5 unit. Means what? You can take the centimeter from a fixed point A on a given line. Consider this a fixed point A, and from this we will take the distance of 3.5. It has treated as the point B. Okay, such that AB is equals to 3.5 units. Okay, you can take the centimeter instead of the unit. From B, mark a distance of 1 unit. It means that 1 centimeter, and mark the new point as a C. From this, you take the point C, 1 unit distance or 1 centimeter. Okay, and mark a new point as a C. Find the midpoint of AC. Find the midpoint of AC. O is the midpoint of that AC. Okay. Draw a semicircle with the center O and radius OC. With the center O and OC as a radius, draw this semicircle, taking O as a center, OA as a radius, or OC as a radius. Okay. Draw a line perpendicular to AC passing through B and intersecting the semicircle at D. Okay. Now from this point B, draw the perpendicular. Okay. And it intersects this line segment to this semicircle at the point D. Okay. Therefore, intersecting, draw a line perpendicular to AC, passing through B and intersecting the semicircle at D. Then BD is equals to root of 3.5. This distance is nothing but the root of 3.5, which we want to find out. Now, how it is the geometrically, we also with the help of the Pythagoras will do it. Okay, this BD is equals to 3.5. More generally, to find root x for any positive real number x, we mark B so that AB is equals to x. Okay, this AB is equals to x in general, and as in figure, take the C so that BC is equals to 1 unit. Okay, then as we have done for the case of, in the above examples, we have taken x is equals to 3.5. Now see this figure. From this, in general, if I want to find out the square root of 7.5, okay, 7.5. In general, we take it as a x. Okay, this distance are as a x. Take AB as a x extend this up to the point C with the 1 unit. Okay. We now prove that is then this BD is nothing but this BD is nothing but the root of x. We will prove this with the help of the Pythagoras. This BD is nothing but the x. If we take this AB distance as x, extend up to the 1 unit, take the O as a midpoint, draw the semicircle, draw the perpendicular, and this distance BD is nothing but the root x. Then how it is, we will prove with the help of the Pythagoras theorem. Notice that in figure OBD is a right angle triangle, okay, and this is its a hypotenuse. Okay, it is a hypotenuse, and it is nothing but the radius of the circle. How to find out the radius of the circle? AC is the diameter. Its value is x plus 1 divided by 2. It's a radius of the circle, and therefore here we have OD as a x plus 1 upon 2. This is the OD distance. Okay, this OD, OC and OA all are the same. Next we will find out the OB distance. How to find this OB distance? We know OC. What is the OC? This distance is x plus 1 upon 2. This. Suppose I want to find out this OB distance, then I will write here. This distance OB is equals to, again I will repeat here, OB is equals to AB minus AO, okay, or OA. But OA is nothing but the OC. OA is nothing but the OC, okay, and therefore AB is equals to x minus this distance OC, which is the x plus 1 upon 2. If we simplify, that is a 2 into x. Here you will get 2x. It has a minus sign in bracket, x plus 1, this whole divided by 2. If you open the bracket, then you will get 2x minus x minus 1 upon 2. And here 2x minus x, you will get x minus 1 upon 2. And hence this OB is equals to x minus 1 upon 2. Now in the right angle triangle, we know the values. Which are the values? We know the OB. What is that OB distance? It is a x minus 1 upon 2. We know the OD, x plus 1 upon 2. And in this way we can find out the BD, okay, with the help of the Pythagoras. Okay, if I join here, then here we get the right angle triangle. This BD square is equals to OD square minus OB square. And what about the OD square? X plus 1 upon 2. Now the calculations. X plus 1 bracket square upon 2 square means what? 4. Therefore both of them have the same base. Okay, x plus 1 here bracket square upon 4 minus x minus 1 bracket square upon 4. And therefore here you will get x minus x plus 1 bracket square minus x minus 1 bracket square, and this whole divided by 4. Okay, now next we can expand this. X plus 1 bracket square means what? X square plus 2x plus 1 minus, in bracket again expansion of this, x square minus 2x plus 1. As the outside this bracket there is a minus sign, the sign will change. Here x square plus 2x plus 1 minus x square plus 2x and lastly minus 1, and this whole divided by 4. Now plus x square minus x square get cancelled, plus 1 minus 1 also get cancelled, and this 2x plus 2x, that is 4x upon 4, and hence this BD square is equals to x. Okay, this distance BD square is equals to x, and therefore BD is equals to root x, and in this way we have this BD is equals to root x. This construction gives as a visual and a geometric way of showing root x exists for any real which is the greater than 0, it's a positive. If you want to know the position of the root x on the number line, then let us treat the line BC as a number line. This BC as a number line. Okay, take B as a origin, with the B as a 0 and C as a 1, coordinate of the C as a 1. Okay, and so on. Draw an arc with the center B and the radius BD. This as a origin, BD as a radius, and if we draw this curve, then this B distance is nothing but the root x, which is on the number line. And what about here? This distance is minus x, as we are treated this as a origin, this as a 1. Okay, and this is nothing but the root x. Okay, the point E represent the root x. Okay, now the next, we now list some identities relating to square roots. Okay, which are useful in various ways. You are already familiar with some of these from your earlier classes. The remaining ones follow from the distributive law of multiplication or the addition of real numbers, and from the identity x plus y into x minus y. Then here you will get x square minus y square for any real numbers x, y. Okay, now let us start. Let a and b be the positive real. Then the root of ab is equals to root a into root b. Root of a upon b is equals to root of a upon root of b. Next, root of, in bracket, root of a plus root of b into root of a minus root of b is equals to a minus b. Here we will apply the formula. What was that formula? X plus y into, in another bracket, x minus y, and then here you will get x square minus y square. Similarly here, a plus b, a minus b, that is the root of a plus root of b. In another bracket, a root of a minus root of b, and therefore here root of a bracket square minus a root of b, here b bracket square. Root of a square means what? You will get a minus b, and this is the answer. What about the next? That is a, in bracket, a plus root b into a minus root b, and here again you will get here a square and the root of b square means what? You will get b. Okay, I will write here a square minus root of b, so bracket square. Therefore here you will get a square minus b. What about the next? This is the normal multiplication. That is this root a multiply the whole bracket root c plus root d. In the next bracket, root of b into root c plus root d. Okay, Now here multiplication, root of a into root of c plus root of a into root of d plus root of b into root of c root of b into root of d. Okay, what about here? This is nothing but the root of ac plus a root of ad plus a root of bc plus a root of bd. Okay, this is the multiplication. Now next, root of a plus root of b bracket square. Again, this is also simple. We can write here root a bracket square plus 2 times root a into root b plus root of b bracket square, and here you will get root of a square means what? A plus 2 root a into root b plus root of b square means what? B, and overall here you will get a plus 2 root of ab plus b. Okay, now we will solve some examples. The first is in first bracket 5 plus root 7 into in second bracket 2 plus root 5. Now their multiplication. First we will multiply this 5 with this whole bracket, that is 5 in bracket 2 plus root of 5. Next 7 will multiply the whole bracket, root of 7 2 plus root of 5. Okay, and their multiplication 2 into 5 will get 5 into 2, 5 into root of 5, 2 into root of 7, and next root of 7 into root of 5, and overall here you will get 10, 5 root 5 to root 7, and root of 5 into root of 7, here you will get the root of 35. Okay, and hence you will get here 10 plus 5 root 5 to root of 7, and here root of 35. This is the answer. Okay, now the next problem. 5 plus root 5 and 5 minus root 5. Again we will apply the formula a plus b, a minus b, then here you will get a square minus b square. 5 square means what? 25. Root of 5 square means what? 5, and their subtraction is 20. Therefore the answer is 20. Next, root 3 plus root 7 bracket square. Now expand this by using the a plus b bracket square. Okay, here a plus b, apply this formula. Here you will get a square plus 2ab and plus b square. That is root 3 square plus 2 into root 3 into root 7 plus root of 7 bracket square. Root 3 square means what? 3. 2 into root 3 into root 7, that is a root of 21, and hence it is a root 2 root of 21. Root 7 square means what? 7. 7 plus 3, you will get here 10 plus 2 root of 21, and hence the answer root 3 plus root of 7 bracket square is equals to 10 plus 2 root of 21. Now the next again a minus b into a plus b, a square minus b square, that is the root of 11 square minus root of 7 square. 11 minus 7, you will get 4, and this is the answer. Now the next, rationalize the denominator. Okay, now what is the term here? 1 upon root 4. Now here multiply multiply numerator and denominator by root 2. Okay, and therefore here 1 upon root 2, here if we multiply with the root 2 into root 2, here you will get 1 into root 2, it's a 2, root 2 into root 2. Okay, and therefore here the denominator is a rationalized, and that's equals to root 2 upon 2. Okay, now the next example, what is here? Rationalize the denominator of 1 upon 2 plus root 3. Here we have 1 upon 2 plus root 3. Here multiply n and d. N means what? Numerator. N and d. D means denominator. N and d by, it's a conjugate part. What will the conjugate? 2 minus root 3. Multiplied n and d by 2 minus root 3. Therefore we have the expression 2 plus root 3, and that's equals to 1 upon 2 plus root 3. Here 2 minus root 3, and to the denominator 2 minus root 3. Again a plus b, a minus b, and 1 into 2 minus root 3. Here you will get 2 minus root 3, and to the denominator here 2 square minus root 3 square. Okay, therefore here you will get 2 minus root 3. 2 square means what? 4 minus 3, and here 2 minus root 3 upon 1, and therefore there it's a, after rationalizing the denominator, 2 plus root 3, and that's equals to 2 minus root 3. Okay. Okay. Next example. Now for the next example, what is that? 5 upon root 3 minus root of 5. Okay. Again, multiply n for numerator, n and d, d for denominator, by the conjugate of root 3 minus root 5. What is that? Root 3 plus root of 5, and therefore 5 upon root 3 minus root of 5 is equals to 5 into root 3 minus root of 5 upon, it's a conjugate part is a plus 1. Therefore here root 3 minus root of 5 into root 3 plus root of 5. Again this 5 as it is. Here root 3 plus root of 5 upon a minus b, a plus b into, therefore here you will get root 3 bracket square minus root of 5 bracket square. Okay, therefore 5 in bracket root 3 plus root of 5, and this root 3 square means what? 3 minus 5, and here 5 in bracket root 3 plus root of 5. 3 minus 5 means what? You will get minus 2. Okay, and therefore the expression is that 5 root 3 minus root of 5, and that's equals to minus 5 upon 2 into root 3 plus root of 5, and in this way. Okay, now the next example. Rationalize the denominator of, what is the example? One upon 7 plus 3 root 2, and this equals to, here again we say it's a conjugate part. Multiply n and d by the conjugate part of 7 plus 3 root 2 is 7 minus 3 root 2. Okay, and therefore 1 upon 7 plus 3 root 2, that's equals to 1 into 7 minus 3 root 2. Here 7 plus 3 root 2, 7 minus 3 root 2. Okay, and their multiplication. What is that? 7 minus 3 root 2. Okay, again here a plus b, a minus b. Yeah, 7 square minus 3 root 2. It's a bracket square. Now next, here 7 minus 3 root 2. 7 square means what? 49, and minus 3 square is 9, root 2 square is a 2, and therefore 7 minus 3 root 2 upon 49, 9 into 2, 18. Okay, and here the subtraction, it is 39. Again here you will get 7 minus 3 root 2. Okay, it is subtracted, and here you will get 31. Okay, and hence the denominator is a rationalized, that is 1 upon 7 plus 3 root 2, that is equals to 7 minus 3 root 2 upon 31. Okay, you can check this here. Okay, 7 square 49, 9 into 2, 18, 49 minus 18, here you will get 31, and in this way denominator is rationalized. And in this way we have completed all the first part of exercise 1.5. In second part I will explain the full exercise 1.5 and I will give the link of this my second video in the description box of the first part, also as well as in the comment box. Okay, I will see in the next video. Till then, goodbye.